Well, good evening and welcome to this webinar presented by the IET's Anglian Coastal Local Network, which represents members in Norfolk and Suffolk. Welcome also to folks from other parts of the UK and indeed globally. I'm delighted to welcome you all. I am Kevin Foster, Chairman of the Anglian Coastal IET Local Network, and I will be your host for this evening. Now, we'll leave questions until the end of the presentation, so please, if you think of a question, use the Q&A panel in Zoom, not the chat panel. So if you wiggle your mouse near the bottom of your screen, you will see the Zoom taskbar, and you can select chat or Q&A. So please use the Q&A for questions. So the webinar will be recorded and we will try and get through as many questions as we can in the time. So without further ado, I'm delighted to introduce our speaker, Peter Scott. Peter is a futurist, author and technology expert. A master's degree from Cambridge University led to 30 years of working on enterprise computing for NASA's Jet Propulsion Laboratory. A parallel career in business coaching and human development added a uniquely valuable perspective on the implications of artificial intelligence development. Peter teaches individuals and consults for businesses on how to thrive in the coming era of technological disruption. He's appeared before highly diverse audiences in several countries, including testifying before a British parliamentary group on the impact of AI and giving 2 TEDx talks. So Peter, over to you.
You cannot move today without tripping over some piece of AI hype. But what if this isn't hype? Andrew Ng is a co-founder of Google Brain and a former vice president of Baidu. He's a professor at Stanford and a director of its AI lab. He's not a pundit trying to get eyeballs on a blog. So if there's a likelihood that AI could have as pivotal an impact on our species as the invention of electricity, we ought to be paying attention. So at this point, I'd like to put up a poll. And if you could make that come up, please. We're going to take some questions while I go over what we'll be talking about in this. So the poll has 2 questions. Number 1, I have a good understanding of what AI is. Just answer according to whatever your own standards are. And question number 2, I feel prepared for the changes AI will bring over the next 10 years. I'll wait for those answers to come in while I tell you that this talk is about giving the big picture of AI, to visit some of the reasons why we ought to pay attention. I'm only going to talk about what it is enough to inform that perspective. We're going to talk about it, what it can do and what it cannot do. We'll talk about some of the governance issues and the ways in which governments and other bodies are looking at constraining it. And then we'll get into the further future. What's a little bit past what we can see? So it looks like the polling has finished. Thank you very much. So if you could share those, thank you. Good, so most of you, the median result is that you agree somewhat. You have a good understanding of what AI is. Fantastic. Now I know who I'm talking with here. You got some experience. Feel prepared for the changes AI will bring over the next 10 years. Median result there is between disagreeing somewhat and neutral result. Fantastic. This is good data, by the way, when we have this many people. So let's save those answers for later. We are on the verge of a second great shift in the paradigms of how we relate to computers. You know, we started from this. Don't try and read this, please. I don't want any casualties here, but some of you will recognize this as part of a manual for IBM System 360. A quick show of virtual hands. How many of you have dealt with something like this? This is part of my history with computers, and this is how we used to have to deal with them. The point was that the computer demanded you meet it on its terms. You had to go into an air-conditioned room and be part of the priesthood that was there to serve it. If you got one instruction even slightly wrong, it was not going to do what you wanted. But that has changed. Now the expectation in the meantime was that we were going to have personal computers, but that they would look like this. And what this demonstrates more than anything else is that we suck at long-term predictions. I'd still really like to know what that big steering wheel is that they thought we would need on a personal computer. But now the expectation is that our interfaces of computers will look like this. It's a frame from iMovie. It's engineered to be as intuitive as possible, and you can start using it without even cracking open a manual. And if someone puts out something that's not so easy to use, Premiere, then most likely people won't use it. Most likely they will only use it if they have to, if they have no other choice. If they have the choice of using something that's this easy to use, they will. So now the computers, the expectation is that they will meet us on our terms. But the next shift is going to be that they will adjust to us individually, not just for some average person, but that they will know who you are as an individual and just their interfaces and output according to that. Now, that hasn't happened yet. So the best I can show is a robot scratching its head. But what's going to fuel that is AI that understands you, how you communicate, what your levels of expertise are. And this is going to be the next level of user interface. Now, what's driving AI? What makes it such a big deal? And why people are making these bombastic, outrageous predictions for it is exponential growth. And you're an audience of engineers, so I understand about logarithmic charts and Moore's law, which drives the density of transistors on computer chips. And there's a chart of that. Same principle also drives down the cost of hard drive storage and affects the rate at which we can communicate over copper and fiber and over cellular networks. And at that speed, I think we get to terabit rates in about another 9 years. And then we have the number of devices connected to the internet, which has gone according to a curve like this over that displayed time frame. But that's also driving a network effect, which says that the utility of a network is proportional to the square of the number of devices connected to it. Where if you are the only person that's got a telephone, all you can do is talk to yourself. It might be intelligent, but not very entertaining. Someone else has one, you can have one conversation, and so forth. It goes up. So when you put all of this together, you've got these multiple layers of exponential curves plus parabolic network effects that mean that anything that lives at the intersection of all of this is growing at a phenomenal rate. And that is artificial intelligence. Now, our current models of artificial intelligence learn in machine learning in 3 different ways. We have supervised learning, we have unsupervised learning, and we have reinforcement learning, which I will go into. But all of them depend upon big data, lots and lots of data. If you have a lot of data about anything, you can think about putting it into deep learning. And this is one of the things that separates computers and artificial intelligence from us. We can learn from single examples. Child that meets a rabbit for the first time can recognize rabbits thereafter, puts it in the class of furry things that I like to pet, and it understands that. Computer is going to need to see 100,000 images of rabbits before it gets good at recognizing them. We can even do zero-shot learning, which is to say that I could describe some mythical creature to you, like, say, hippocorn, okay? Hippopotamus. Imagine something, body and head of a hippopotamus, got a horn like a unicorn growing out of its head. hippocorn, all right? You've never seen one of those before, but now if you ever do, you'll recognize it. And you go, oh, that's what that weird guy was talking about, the hippocorn. Zero-shot learning. Computers nowhere close to doing that. But what they can do when you give them a lot of data is often better than what we can do. So let's look. Supervised learning is when you've got examples of what the right answer should be. You feed it enough of those, and it can, for instance, recognize handwriting. It can recognize voices, it can tag images. Unsupervised learning is when you've got a lot of data and you want to know, what does this mean? I'm not sure what's in there, but here's some metadata. Draw some correlations for me. So for instance, it was discovered when they fed a lot of images of retinas of people's eyes into unsupervised learning, along with metadata about the patients. They found correlations between the images and the state of the health, whether they were a smoker, how old they were. But they also found, for instance, that they could tell the gender of the person they were looking at. In fact, even after experts were told this, they could still do no better than chance by looking at images themselves, but the AI could tell to 97% fidelity whether a retina belonged to male or female. Now, there are better ways or easier ways of telling someone's gender than staring into their eye. This isn't the point. The point is that prior to this, no one had a clue that your retina was correlated to, linked to your gender in some way. AI discovered that. And then we have reinforcement learning, which is where you train something over and over again and give it a virtual reward for getting the right answer. This is how we train a lot of our self-driving vehicles. And sorry, the poll was getting my way. I am going to stop that sharing, close that window, and all right. So for instance, training robots to pick up packages, training them to play the stock market, give them a little reward in the form of this number gets bigger, that's what you want. Every time it gets a better result, eventually they learn how to do what we want. What this revolution in learning, machine learning, has meant is very interesting when you compare it to people. See, our trajectory as we develop as humans is that we start out being just able to manipulate our world. In fact, when we start out as a very young baby, we don't even have the concept of object permanence. We have to learn that. Baby thinks that when mommy leaves the room, she ceases to exist. Explains the crying. But we learn that, and then we learn how to pick things up, put them down, move them on top of other things. And then we develop emotional intelligence and social intelligence, and we learn to reason. And as if we're going further and further in school here, and then we learn abstract symbol and logic manipulation, and eventually you get a PhD. But the interesting thing is that computers, it's the other way around. We started out with the PhD stuff, being able to do calculations that were that required a lot of expertise for people. Then we got into reasoning systems, and then we started tackling the really hard stuff, which is understanding the real world, pattern recognition, being able to detect objects in the real world from images is phenomenally hard for computers. It's natural for us. But that's a very difficult thing. And now we're in the era of connecting that perception with reasoning. Ground zero for that is self-driving vehicles. Now, we look at that object recognition, for instance, we will see that the neural network that does this has learned in its early layers how to recognize, for instance, diagonal lines. And this is something that we can look at human nervous systems also and see that they likewise have nodes that react to diagonal lines. So it looks so far as though the machine learning, the deep learning networks have learned how to recognize images the same way that we do it, because then there are nodes in the network that know how to recognize faces or cats or whatever the target is. Well, let's explore that for a moment. I am going to show you some images here. And what I want you to do is call out as fast as you can what it is that you're looking at, just one word each. Now, this actually works even though I can't hear what you're saying. Trust me on this, all right? So as we go through these, just call out as fast as you can, what am I looking at? Now, I'll bet, based on some experience here, that when it got to this slide, it took you a fraction of a second longer to come up with an answer. Because most of you probably have not seen goats in trees before. And so you had to do something that AIs, almost all of them, cannot do, which is what we call a double take. You said, wait a minute, that doesn't register. Let me take a closer look. Then you realize it's a bunch of goats in a tree. Now, this is actually in Morocco, and it's not a made up picture. These goats are actually sitting in the tree. The locals there take tourists out to see these goats in the tree and then charge for taking pictures with them, because they tell them that these are tree climbing goats native to Morocco. In fact, they're not. The locals there go out in the morning and put the goats up in the trees. They can't get down. And then they bring the tourist over and make money from showing them this. This picture fools AIs. When you feed it to a couple of them, one of them thinks it's birds because it's used to seeing birds in trees, not goats. Microsoft Azure thinks it's a group of giraffes because Azure has a thing about giraffes, it turns out. Which means that when it comes to a question where the answer should be, I don't know, that's where AI has a problem. Some people make hay from this. Janelle Shane is an AI researcher who asks question, does anyone have a picture of sheep in a really unusual place? It's for pranking neural network. She takes pictures like that other one and then sees what answers neural networks give for them. One of the more unusual requests regarding sheep to appear on the internet, at least in the context of computer science. Not going to ask about any others. And so that's enabled her to write a book about it. This is not the only example of AIs making mistakes. One that impacts people in the United Kingdom. The United Kingdom police have a porn spotting AI that gets confused by pictures like this. Okay, so you look at this and you go, well, all right, I kind of see where it's going wrong. And it thinks that sand dune is a, you know what, all right, we'll give it a pass on that. But let's meet this guy, Tom White. He has got some pictures and he is in front of something called Mustard Dreams, which violates or is tagged as pornographic, erotic material by every platform that he tries to share it on. Now, this is something where you can't really look at that and go, okay, I get it. Now, Tom knows what he's doing in constructing these images. He knows how to make them fool the AI. And so now we start to get the idea that the AI is not thinking the same way we are. Those recognition algorithms that are operating in the neural networks have not learned the same lessons we have. It's a bit more fragile. Which brings us to discussion of bias. Issues that are currently important in the deployment and use and development of artificial intelligence. The tweet heard around the world with respect to this, which I've censored slightly, occurred in the Google Photos app, which does tagging of images so that people can search the ones that are on their phones. And this user did not like the way that it tagged the picture in the bottom center. The response to this, by the way, was that Google stopped labeling any images as gorillas. And as far as I know, that is still their response, which is suboptimal, obviously. But how did it make that mistake in the first place? It's not that Google is a hive of racists trying to promote agendas of hatred. No one at Google had that intention. It comes down to big data. That data wasn't big enough, and it had seen too many pictures of gorillas and not enough pictures of Black people. So bias can be perpetuated or created by AI if it lives in the data. It can live in the absence of data if there's not enough for what it wants to do. So that is one of the ways in which bias emerges from AI. Fraud is intentionally perpetrated bias. Here are some stop signs with slight graffiti on. It says stop in North America, at least. Now, no one would get out of a ticket for running this sign by saying that, hey, it was defaced. We recognize this as a stop sign with some minor distractions, but to a computer, the algorithms looking at this think that it is a 45-mile-an-hour speed limit sign because that is very carefully chosen graffiti. Turns out that there are fragilities in the image recognition algorithms that can be exploited if you know what to look for. This has obvious ramifications for people wanting to sabotage self-driving vehicles if it's this fragile. These people do not exist. In fact, all of these pictures were taken from a website that says that whose name is thispersondoesnotexist.com. You can go visit it, you can click a button, and you can generate pictures like this as fast as you can click the button for as long as you like. It synthesizes them through doing basically facial recognition in reverse. That's got some obvious impacts and consequences in being able to embellish fake social media accounts. If you've got a bot and you want it to promote some divisive agenda, then it should have an avatar, it should have a picture next to it. You can make those up as much as you want. And this is the progress that there has been in developing those images. In the space of 3 years, we went from the picture on the left that was the state of the art in 2014 to the one on the right, which was how well we were able to generate fake images in 2017. At that point, it was still possible, if you look carefully, in some or most cases, to be able to tell. It's getting harder now. If you want to be able to tell the difference, look for violations of bilateral symmetry. Look at the ears, look for different jewelry, for instance, on each ear, look at the eyes, look at the hairline, and especially look at the background, because these algorithms tend not to take care of the background, and that will end up being distorted. And AI can now also mimic voices. Put these together, and you've got a very capable bot capable of doing a large number of things on social media or elsewhere. So here we had a case where someone in the UK thought that he was talking to his boss, and it was in fact an AI imitating that voice. Enough data in the form of recordings of that boss's voice is all it took. Now, what about the text that those bots might need to generate? And here's a description of the GPT-2 system. That is an AI trained upon internet text. The first thing that strikes you about GPT-2 is its simplicity. And I'm not going to read the rest of the slide, although you can. I'm not a fan of slides that are pure text. The reason I put this one up is that this sentence I read was the only one written by a human. The rest of it was written by GPT-2 after it was given that sentence. Read it closely enough and realize it's a bit of a non sequitur, but this is capable of generating that level of prose. And now, and you've probably heard about GPT-3, which has 100 times as many parameters, is able to go much further in its capabilities. Okay. Privacy is another currently very big issue in artificial intelligence. Facial recognition is a very popular technology in the United Kingdom, of course, and in China, where this police officer in the airport is wearing glasses that are equipped with a screen that can tell her who she is looking at in real time. Again, that's not like this year's technology. That's at least 3 years old. So that's something that is not even bleeding edge at the moment, which means that it's now being pushed further down the utility stack. And places like New York School District wants to use that technology to look for guns and other threats. Obviously, there's no single right answer in this, and it will change according to the venue, the culture, and the society that you're in. But what's undeniable now is that the technology exists to change the way that we are doing this. Because, for instance, listening in on conversations is impractical for, say, the National Security Agency, the United States, to listen to all the phone conversations in the world, even though it had the hardware taps to make that more or less possible, as long as it had to do it with humans. But with artificial intelligence, it absolutely can do that. And here's some of the other technology. You can now get this yourself. You can buy home security cameras that not just record video and broadcast it, but can tell whether they're looking at people, can tell whether they hear breaking glass. Accountability is an interesting one. Lets you illustrate with an example of the self-driving car. If it gets into an accident, who should we hold responsible? Legally, at the moment, the answer, there's one answer to this, but the lines might start getting blurred. Is it the car, or is it the driver, or is it the owner of the car, or is it the person who configured the settings of the car? So that if someone, say, had configured their car, let's say it's a Tesla, they configured it to be on Mad Max merging mode, which is a real thing, that's what it's called. If they configured it for the Mad Max level setting and then let teenager take it out, does that person have some culpability for an accident? Or how about the company that made it? Deep pockets, of course. Or what about the third party that developed the self-driving software? Or the people who trained the self-driving vehicles on the test labs that are the place where that's trained? Or the umpty million drivers of the cars that provided the test data on which it was that training was based. A little hard to sue them, but right now, if you're driving a smart vehicle, your driving record becomes part of the contribution to how other cars will learn how to drive. All right, so accountability. I know a lot of you are looking at this and going, oh no, not the trolley problem. Bear with me, it's not what you think. For those of you that don't know what this is a problem that was devised by philosophers a long time ago, hence it's a trolley or streetcar. And in this mind experiment, you are next to a switch looking at a trolley barreling down the tracks to where some evil villain has tied 5 people to that track. And the switch you are next to can cause the trolley to go down another track where we'll encounter someone that's presumably tied there by the same evil villain, but just one person. Now you are, because this is a philosophical thought experiment, imbued with the sure and certain knowledge that the only choices are run over and kill 5 people or 1. Do you pull the switch? Okay, so this problem has been done to death by the media talking about self-driving cars, because they say one day a self-driving car will be faced with a situation where a little old lady is crossing the road in front of it, and its only choice to make in time will be to swerve onto the sidewalk and run over a school kid waiting for the bus. This is very mediagenic. This is not likely to be a real problem for a long time. But here's where it really does come in. We are very close now to self-driving vehicles being, on average, better than human drivers. Now, there will, for a long, long time, be situations where the car does not make as good a decision as most human drivers would. Anything novel. Because remember how we need the double take. Anything that's not as novel to it as goats in a tree is going to be a problem for it. Human driver can do the double take. So, but what if the self-driving vehicle is on average 10 times better than a human driver, which means that you deploy those, there will be 1/10 the accidents. You have a real life trolley problem now. Do you deploy those and accept the accidents that would have been avoidable if a human had been driving at the time, or not, and accept the greater number of accidents? We're on the verge of having to make that decision, and you can generalize that decision because this is a specific case of workplace safety in a robotic process automation environment, which means that there are other places where this issue is happening or is shortly about to happen. And then we have repeatability, because often as an issue in processes, we want a computer program to come up with the same answer each time you run it on the same data. Why wouldn't it? Well, if it's artificial intelligence, it's operating by basically optimizing a function in multi-dimensions. If you've got a 2-dimensional function here with local minima, its job is to find the best local minimum that it can. But it's over a big space. So as engineers, you know that you can't really afford the time to find the absolute best global minimum, that what you do is you will find one that's probably close to it. But the way you start out on that is essentially using a random number to find a starting point and then walk around until you find a satisfactory local minimum, which means the next time you run that algorithm, it may find a different one, a different answer. That's not acceptable in many environments. It's a question we're going to have to ask ourselves more and more as we deploy AI more and more. And then there's explainability. Because in some of those environments, we need to answer questions like, why was this loan claim denied or approved? Why was this person hired or fired? And why was this medical diagnosis made? All environments in which AI is being used right now to produce better results than human beings can provide, because we've used big data to train them, and they've learned well enough to make better decisions about insurance, about loans, about hiring, about medical diagnoses. But what does it mean to explain that when someone wants to know, someone and their lawyer wants to know why that decision was made? Because our idea of explainability is different. If the car turned left and you want to know, why did the car turn left there? The answers that you might get may not be useful. It may say these things. And none of those are what we're looking for. Probably we're looking for that, but there's context, there's background behind that. Why did you turn left? We're leaving out, you usually don't do that. Why did you do something different this time? Explainability is a hard problem in AI right now. And then we have employment. And this is a big, big, big thing, of course, because with projections like this, that we're going to have 47% of jobs automated. And we can start looking at the ways in which things are more or less likely to be automated. But as an example, that this doesn't apply just to mundane, rote minimum wage jobs. There was a bake-off between lawyers and an AI in vetting non-disclosure agreements, which is something lawyers do a lot. So we have big data, so we can train AI to do it. And the results were that the AI was as good as the best lawyer, but whereas the best lawyer took between 156 or 51 and 156 minutes, I assume that's actual in this case, not billable, the AI took 26 seconds. So if you're running a law office, it's no contest at this point. Your next question is, how much does this cost? That doesn't mean they're going to replace Perry Mason arguing in front of a jury, but anything which is where there's big data and it's rote and it feels boring to a human is going to be great material for an AI. They can be used, as we've seen, for hiring. Here is one of several companies that deploy artificial intelligences for interviewing potential new hires at companies. And Google Duplex is a technology that many of you may have seen demonstrated that can hold conversations in voice over the telephone at advanced levels of comprehension. I'm going to skip over that and
our focus was to see how far we could push systems to create digital human representations.
An example here of a technology called Mica from Magic Leap. It hasn't made it to market yet for reasons unrelated to the viability of the technology, I believe. But this is putting the ability to construct digital representations of people together with artificial intelligence is able to establish eye contact and answer questions. If you put this together with the conversational ability of Google Duplex, then we seem that we might not be that far off from the era of the science fiction movie Her, where a guy fell in love with the operating system on his mobile phone. Moving ahead. Next slide, please. There we go. And Samsung has the neon technology now, which is a little more recent and applies that to full body. These people all actually existed, but the animations and the movement and this talking that they are doing now did not. That was created by AI doing essentially synthetic motion capture. Talking of emotions, recognizing emotions of people is now a thing that can be done in computers. This is Rana Al-Kalioubi demonstrating the capabilities of Affectiva's software, which can, in this case, recognize this person is joyful, not a difficult one to do. But it can also be used to tell whether you're too angry or too tired to drive a car. Now we have the question of should we be deploying that technology? Because now we can. And this is big business. There's a summit that was held a few years ago just for exploring how you can use emotional artificial intelligence. That's not just a research tool now, it's big business. Which means that governments are now looking at what the impact of artificial intelligence would be. Back in the Obama era, won't address what sort of progress was made in the meantime. We had a report out from the NSTC on preparing for the future of artificial intelligence. So the US was making progress on this. And then some Senate hearings again back in the Obama era. In the UK, you've got the APPG-AI, the All-Party Parliamentary Group on Artificial Intelligence that I went to speak to. I've got to give them a shout out because they have heard from extraordinary number of experts, quite, in my opinion, the most well-educated legislators, lawmakers, policymakers that I'm aware of anywhere in the world as a result of how many people they've talked with. But now this is getting commoditized. We are seeing now that you can, Amazon, as with every technology, is developing user interfaces for operationalizing this and commoditizing it so that you can fire up a console for doing it. In an Amazon case, it's called SageMaker. What does that mean for, if we look a bit further into the future? Because that's something that's very hot topic, obviously, in the news, most of it dominated by big figures like Elon Musk, serves as something of a lightning rod for this sort of thing. But it was pointing out real issues, like we already have autonomous lethal weapons. These ones are deployed in the Korean demilitarized zone. But there's a question about whether they should be deployed elsewhere, which is what caused Stuart Russell and others to make a video that you may have seen about the possibility of developing mini drones that swarm and are armed with explosive to use facial recognition technology to assassinate selectively large numbers of people. It's doable right now. Now, there is still some question, some debate between professionals about the impact of this, because if you're an engineer, it looks like this kind of comparison. And this is true right now. There's no question about that. You have to look a bit further out. You have to have a leap of faith that we are going to make some breakthroughs in technology. But those breakthroughs will happen. And when they do, artificial intelligence is capable of being creative by accident. And some examples here that you can have a quick look at, but without any intelligent consciousness at all, AIs came up with what we would call Bond villain level genius of cheating in the tasks that they were given. My favorite one is the one that was analyzing images of a street from a satellite, was then told construct the image equivalent to the street view, which requires throwing out a lot of data, and then construct back the equivalent satellite image from that street view, and it found that there was data in there that it shouldn't have been able to get. Turned out that it was steganographically encoded in high frequency noise, otherwise would look like noise, in the intermediate image. So there are people concerned about this. There's a bunch of them, computer scientists and security professionals around the world gathering in Puerto Rico, who then formed the Asilomar principles, something you can look up, which is a bunch of guidelines for the safe development of artificial intelligence. Similarly, the Toronto Declaration is declarations with respect to human rights in the age of machine learning and responsibilities of private sector. With respect to those, they have not gotten that much traction. How should we think about this? In my final slides here, Bill Gates says, observe, we always overestimate the change that will occur in the next 2 years and underestimate the change that will occur in the next 10. And this is because we know we have exponential growth here. It does not come intuitively to our minds as people. Yes, I know all of us here understand what y equals e to the x means. We can do things with it, differentiate it, integrate it, and all of that. But nothing in the natural world doubles as many times over in size as computing performance has. It's not intuitive to us. So Bill Gates' observation looks something like we're making a linear projection that goes out 2 years and looks better, but is after 10 years is woefully behind. Now, gave away a little bit of my slide there. Here's how unintuitive that is. Suppose you're in the design phase. Suppose that you are faced with a task that will take 5 years of computation to achieve. And such tasks do exist, things like protein folding or environmental simulations at high resolution. And they're not often embarked on for reasons of patience, but they exist. Now, what's your optimal strategy for executing that? Our intuition says, get started now. It's drilled into us by our parents, right? The sooner you start, the sooner you're finished. As a matter of fact, that is not true when Moore's law is in charge. In that case, your best strategy is to do nothing for 1.5 years, because then the hardware will be twice as fast, and it will take 2.5 years instead of 5 to finish, which means it will take 4 years. You'll be done 1 year earlier. And even if you wait 3 years, then it'll be 4 times as fast, which means that it will take 1.25 years. Will be done in 4.25 years, still faster than the poor schmuck that started to begin with. It's not intuitive, but it's undeniable math. And what does this mean practically? Well, if you're in the design phase of a product that will take 18 months to bring to market, you should size it for twice the computing platform requirements that would currently be cost effective, because then that'll be just right by the time it comes out. So how do we best tackle a future with such uncertainty about the scale of impact that we may face? At the 50,000-foot level that we've been taking in this talk, the approach looks something like something called futures thinking, which has been discussed by Zoe Prosser and others. Now, it takes a long time to explain and to especially to teach, but this is about using a mindset about the future that changes the way that you look at your current situation. It's based upon essentially a derivative. Instead of looking at static images, instead of looking at states, you look at velocities. And this calls for a fundamental shift in our common ways of developing projects and business strategy. Throughout history, we've based that on our ability to predict the future, which allows us to make plans. When I was in high school in Britain, the teachers there could provide career advice because I had a good idea of what the next 20 years would be like in any field. But now, 5 years from now, there will be entire new fields that we don't know about today. We can't do that now. Our predictions are no longer adequate. Our plans are no longer adequate. What we must focus on instead is preparing. And what do we prepare? We prepare ourselves. Futures thinking requires futures thinkers. It is not so much what we prepare for, because we can't know that, as who we prepare ourselves to be. If the changes in store for us are on the scale of the introduction of electricity, the issues we will face call for more from us than technological prowess. We have to ask ourselves, who do we want to be in that AI future? With that, I'll turn the meeting over to our MC.
Thank you very much, Peter, for a very thought-provoking presentation. I can see there are 17, 18 questions at the moment. So I think what we'll do is we'll hand over to my colleague Ian, who will put the questions to you, Peter. And so over to Ian.
Thanks, Kevin. Peter, we've got a number of questions that have come in. The first one is about 3 questions in one. So we'll start with that, see how it goes. So Veselin Kirov asks, can you imagine intelligence without knowledge? That's the first part. Why is expert knowledge representation and use so neglected nowadays by the so-called AI pundits? That's the second bit. And do they think that knowledge is not important, or believe they already have the ultimate general purpose solution, or every particular task requires its own specific approach? So there's like 3 questions amongst there.
Yes, I'll need you to repeat them and take them one at a time. My brain is not as big as it used to be, let alone as big as an AI. So the first one, let's take the first one first, which was...
Can you imagine intelligence without knowledge?
Well, my imagination might be limited in that respect. I am used to a hierarchy which goes from data to information to knowledge to intelligence to wisdom. And so as long as I'm stuck on that, I can't imagine intelligence without knowledge. I think of intelligence as being the ability to create new knowledge from existing knowledge, given pieces of information to come to some conclusion that tells us something new that we didn't know about it. Classic example, Sherlock Holmes observes things that everyone else can see, but puts them together and comes up with a conclusion that we didn't know. But can you do that without knowledge? I think that might be the organizing principle that allows that to be created, but it has no instantiation without knowledge. Next question.
Why is expert knowledge representation and use so neglected nowadays by the so-called AI pundits? So unfortunately, we can't get them to.
I'll interpret that as being a callback to what we call GOFI, good old-fashioned AI, which was rule-based artificial intelligence, where we were developing it based on expert systems and reasoning about our situations. That turned out to be not nearly enough to do things like recognize things in the real world. And then we found that we could get AI to do things that people can't explain how to do. You see, facial recognition as an example. You don't know how to explain how to recognize faces. No one does, but you do it. Okay, if you try, you may start coming up with some sort of tree-based system and heuristics. You may say, well, you know, crooked teeth plus wart on nose equals witch from Snow White. Crown, female with crown and jowls equals Queen Victoria. orange face and comb over equals Donald Trump, you might think you're getting there, but that's not going to get you far enough. No one knows how they recognize faces, but we do it. And if it were true that we could only get computers to do what we program them to do, then we couldn't get them to recognize faces. But we can train them, which is how we learn how to do it. Now, this has definitely overweighted our belief in the power of deep learning. Now everyone thinks that if they can throw together enough parameters, suck down a few megawatts of power into a large enough neural network, they can solve everything. It's definitely gone too far, in my opinion. And at some point, it's got to pull back more towards the reasoning side. I can't tell you what that's going to look like, though. Third question?
Well, shall we move on? Because
okay.
I think there's a number from other people. So
fair enough.
There's one from Norman Watson here that asks, is there another learning technique? I think he's referring back to one of your slides, i.e. providing human rules / rationale that can be included with big data methods.
Right. And that is what I was just saying, the good old-fashioned AI, rules-based systems. And I think it's really interesting to see where do those coexist with the pattern recognition algorithms that we need for anything that can navigate a real world. If you're the place that these cross over is in playing games. We had rule-based systems for learning how to play chess, and you had IBM Watson, but that just didn't get as far as a machine learning approach for playing Go, prior to which it was estimated it would be another decade at least before any system, any computer was as good as people at playing Go, because even the best human Go players couldn't really explain how they made a move. They would just say, well, it was intuition. They couldn't lay it out for you. So then how could you build a rule-based system for playing it? Turn out that you could do it with deep learning, where it couldn't tell you why it made a decision any more than a human did it, but it just did. And I think it's really interesting to look at what's happening with self-driving vehicles, because that is where in humans we have the convergence of those two systems, which Daniel Kahneman calls system 1 and system 2 thinking. We have the pattern recognition going on, which sometimes is all you need for driving. Have you ever had the experience that you drove somewhere and by the time you got to the other end, you realized you didn't remember anything about what happened in between? You were on automatic the whole way. Your pattern recognition was that good. This is not something I can ever do if I'm driving in the United Kingdom, which I avoid now. I've got to tell you that it is a lot harder than what it is over on this side of the Atlantic, just because of how narrow the streets are and so forth. I cannot drive on automatic in the UK, but you have to, at the same time, integrate that with understanding of things like, yeah, if the yellow line is broken on this side, that means that I can cross it to go to the other side, but not vice versa. That's a North American road marking rule. And being able to read and understand signs about which side of the road you can park and when, things like that. We have not made much progress in integrating that kind of, I think, rule-based interpretation with the real world navigation that we already know how to do through deep learning. I think that is the frontier where we'll see the next, well, hopefully that's where the next big breakthroughs will occur, because that's where we need them.
Okay, thanks, Peter. There's a question here from an anonymous person, but they were referenced back to your big data slide and asking the question, how big is big? How much big data do you need to avoid bias?
That's a great question. And of course, the answer is it depends. If it's something like image recognition, the answer is 1 million is good, 100,000 might be enough. There are some systems that are able to learn on less. It's, I think, instructive to remember that every time we train an image recognition algorithm on something, it is starting from scratch. Humans, we learn image recognition based on understanding of the natural world. So we have a place to fit these things in. But an AI that's being trained to recognize dogs doesn't know what a diagonal line or an edge is to begin with. It's got to learn that all over again when it's being trained. So more is better if you're doing unsupervised. So if you're doing unsupervised learning, then hopefully you can find hundreds of thousands of samples, because that's usually the sort of range that produces good results.
Okay, thanks, Peter. This one may be a slightly tongue-in-cheek question from Vladimir. How do you reward a robot during learning?
Well, the boring answer is it's a utility function. So you're just training it to optimize it. We call it reward-based learning because we like to anthropomorphize things. But otherwise, it's just been told, make this number as big as you can. Outcomes that make it bigger are ones that you should prefer. And then it starts learning on those.
There's a question here coming from Robin. I think it's referring back to your philosophical question about you pull the switch to do more damage to 1 or 5 people. So it asks, so you're suggesting that the Boeing Max may have killed fewer people than allowing human pilots make their inevitable mistakes?
Well, okay, I don't know enough about the Boeing Max to answer that, and we're not at that point yet, I think, in aviation, but probably mostly because we haven't trained enough AIs on that. Most airline accidents are due to human error, whether it's the pilot or someone maintaining the aircraft or air traffic control. And so the problem in taking humans out of that loop is one of acceptance, because how many people getting on a plane would be comfortable seeing blinking lights in the cockpit instead of a person, despite the fact that it would not be hard to make it safer. And if we can't train cars to drive on roads, there's no way we can train a plane to go around an airport. It's a much simpler problem. Our success with cars suggests that there's no reason that a plane shouldn't be safer gate to gate with an AI. But 500 lives are at stake on that plane. And our feeling is a principle called shared fate, that we want someone in charge of this up front, where they will be the first to die if they don't get it right. That's a very hard thing to overcome.
Mm. So whilst we're talking about cars Ian asks, why is the auto car regulation, so self-driving vehicles, autonomous vehicles, any different to regulating, say, medicines? We have made these trade-offs for many years, e.g. construction of nuclear plants regulated by safety cases.
Correct. We do make those decisions. They're, I think, in those instances, a little further removed from the general public, whereas autonomous vehicles are in everyone's face right now. The media is all over this. The moment an autonomous vehicle in self-driving mode runs over a cat, it'll be headline news. And that means that decisions made about that will be made by the driven by the emotions of a tabloid reading public. And it's that is somewhat more volatile than nuclear energy regulatory agencies. Although, nevertheless, things like 3 Mile Island and Fukushima have driven a lot of reaction against nuclear power, despite a number of studies showing that it is greener and safer than alternatives that we continue to pursue. Again, this gets down to perception. Do you think that addresses the question, or that they were asking a different question?
I think probably it's as much we can do this evening, given that we can't talk to the people. I think we should move on to the next one, which is from a Stephen Browning, which is an interesting one. He's seen a consciousness presentation which says that we actually hallucinate as to what we will see next before analyzing what we see, single or double take. Is that aspect of interpretation that is unique to us as against AI? So I think what he's saying and asking is, can AI, do the same as what the human does?
So yes, it's a great question. I understand the question. We as humans run our internal wetware biological neural networks in 2 modes. We have, it's all pattern recognition. We have patterns coming in that we recognize, but then we start priming ourselves for what comes next. So that if you have read the letters ARTIFICIA, you have now a great deal of expectation that the next letter is L. And your network is going to be primed to accept that at a much lower threshold than it would have otherwise. So we have this predictive mechanism going on inside our brain. I am not up as much as I would like on the technical aspects of artificial intelligence to know whether we are driving, using that principle to drive it there, but I would expect so.
Okay, thanks, Peter. There's a question around privacy here from someone we don't know the name of. Apart from privacy, how vulnerable is AI algorithms to a hacker manipulating it? Okay.
Well, it depends on who wrote it. Substitute name of your favorite or least favorite software company here. Everything we write has bugs in. At least everything I've written has had a bug. So that will happen with artificial intelligence as well. And the failure modes of artificial intelligence are interesting to contemplate, because the higher the complexity of any program, the higher up the layer of abstraction the failure modes can be, which is to say that instead of a bug meaning just we've flipped a pixel on the screen here and got some noise, that it may decide that the autonomous weapon in the DMZ may decide to fire on the person who's holding up the white flag. And so how vulnerable are they to hacking is as vulnerable as anything else that we write. And the chief vulnerability of neural networks is through their data. So if you're going to hack it, do it through the data.
Yep. There's a couple of questions about learning AI. So one, I think probably I can read a couple of questions here. Does existing codes of conduct for engineers sufficient for AI, or does it need augmenting? How, in your opinion, how can I start a career in AI, and any good courses that you might want to recommend?
Well, great questions. And codes of conduct for engineers. I'm not as familiar with those as I would like to be. I think we have to ask ourselves, to what extent might there be issues in artificial intelligence that would not be addressed by those codes of conduct? And I'm drawing a blank on that. So they may well, I think, those codes of conduct be adequate. But I would encourage the questioner to look at the Asilomar principles, because there's 23 of them that are devoted to the ethical development of safe artificial intelligence. And I think that they would find some interesting and useful guidance in the earlier ones. And the second half of that was courses.
In your opinion, yeah, courses and how to start a career in AI.
Wow. There is so much of this around. It almost seems unavoidable, but maybe that's just because of the water I swim in. For the courses, I would look at what's the institution that you would like to learn from, because a lot of this is available now online. And I think it really depends on what your choices of post-secondary educational institution are. There's just so many places that you can learn AI from now. My head is exploding trying to pick one. I think you can all list the top players in that arena as well as I could. MIT, Stanford, Cambridge, UCL, Edinburgh. And so there was courses and how to get started in learning this. Have a problem to use it on. Find something you care about that you can use this on, because that will get you the best experience. Now, you may have to go through all kinds of other learning processes along the way to get good enough to do that, but have something in mind which has enough data on that you know that machine learning will have the potential of telling you something interesting about it, or doing something interesting with it, and make it your goal to apply it to that. You will learn the most from doing that and the mistakes you make along the way there.
Which leads nicely on to the next question, which is from David, which says, any thoughts on applications of AI to reaching carbon zero?
It's been used already to do that in a number of narrow artificial intelligence applications. For instance, Google decreased the energy usage of their data centers by, I think, 30% or more by using AI to optimize for these things. That's a real impact in the direction of carbon zero. So using this in any environment where you can learn about the expenditure of energy or the conservation of it will matter. It's being used already in numerous applications like that, optimizing energy usage, and well, so much of what we do is optimizing and would benefit from optimizing energy usage, using it to tune anything where there's multivariate data that you have a lot of examples on. That could be pollution, for instance, tuning a car. Why not use it to tune a car or a more complex engine or an industrial process? So yes, it could be used in all kinds of things like that. It's not going to be so much the oracle where you just put in the question, how do we fix climate change? And it sits there for a while and says 42. But applications of narrow AI in all kinds of domain that can produce point solutions, yes, absolutely.
Okay, I think we're probably getting to the point where we need to just restrict it to the next couple of questions if we can. So I'm picking one out here, which is quite an interesting one. Do you believe society is prepared for deep fake in regards to fake news? And is it the responsibility of AI researchers to consider the morality of their developments?
Fake news is such a huge topic, more than we have -1 minutes to do. And are we prepared for that? No, it's our psychology. We haven't been prepared for it for the last 2,000 years, let alone now. And that is an issue. AI just lets us scale that up to unimaginable levels right now. I was surprised by how there was not a more visible impact of that on the 2020 presidential election in the United States, because given the capabilities that were exercised in the 2016 one and how much is possible now, I am awaiting the analysis of why there wasn't more. I suspect that Facebook and Twitter got really good at suppressing and detecting bots. But this gets back to what I was saying about the thing to prepare is us. And that is a fake news, I have to say, impacts me personally. I have lost friends to conspiracy theories. And that's being driven by bots spreading it on the network, driven by people that understand psychology. That psychology is absolutely susceptible to machine learning. So if you feel from my words here a calling to go out and do something about that, please do. Was there a second part to that?
Well, no, I think that's probably a great place to leave it. As always, we've got far more questions than we can actually answer on the call. So I think it's probably best to hand back to Kevin, who can tell us what we're going to do next. But I think we've given it a good go. We've answered 21 questions, so that's pretty good, Peter. So
very good questions. Thank you.
Peter, thank you so much for a fascinating and an extremely thought-provoking presentation, and for taking so many of the questions. Do really appreciate you staying on and taking the questions. I think there's been so many issues that you've raised. It's caused my brain to sort of race between all of these things that you've mentioned. And I think the thing that I'm really concerned about is self-driving cars and how they're going to react to very edge case situations. And I can think of a lot in my own personal sort of driving in the UK, some really kind of edge situations which kind of I've dealt with safely, and I would hope a self-driving car would be equally as safe. But you've raised the prospect here of some very interesting challenges around self-driving cars and indeed other areas. So many thanks for the presentation, and many thanks, Ian, for grouping the questions on behalf of the audience. So I would really like to remind everyone that the recording of the webinar will be made available, and it's usually within a sort of a week to 10 days. It will be up on our community website, and you can see the link to that community website in the slide that I'm sharing. So next, I would really like to draw your attention to our next webinar in the series, which will be about indoor localization in the IoT era, Internet of Things era, and that'll be on the 30th of November. So please check out our IET community website for further details of this and the other webinars. Peter didn't mention this, but the background music that we played at the start of this presentation, and I'm going to play in a few seconds, was composed by AI, and I really like the music actually. So just bear that in mind when I close this out and I play the music. So that just leaves me finally to say, on behalf of the IET Anglian Coastal Local Network, thank you so much for joining tonight, and thank you to the team who put the webinar on tonight. And that concludes the webinar. I'm going to play the music, and you may listen to the music and disconnect when you feel. Thank you.
Thank you.